Right, today we talk about the effective actions and Weinberg, Coleman Weinberg potential. First of the we the final score is the thermal period theory, but before that I want to talk about the zero temperatures. The effective actions can be obtained by the integrations of the effective field theory Lagrangians. In the effective field theory, some happy fields are integrated out, and only the effective Lagrangians remain. But today we want to talk about the 1pi effective actions, which includes all the quantum loop effect. First of all, let's review what is the generating function in the path integral. This is a path integral formalism with the current source term, and we can obtain the generating functional. There is some additional quantity wz, which is called the generating functional of the connected diagram, defined by the exponential of the IW. As the W, such a generating functional of the connected diagram, can be obtained by the LNZ laws of the generating functional. And by the Legendre transformations, we can obtain the third quantity, 1pi effective reductions. The generating functionals originally is the variables of the source someday, but after the Legendre transformation, it explicitly depends on the 1pi effective reactions. And as you already know that the Legendre transformations contains the following properties, like as relation between the Lagrangian and Hamiltonian or the thermodynamic formalism. The first derivatives of the generating functional about the source term is pi, and the gamma, the derivatives of the effective actions about the field is the minus a with the relative minus sign. So let's talk about such a three quantities, generating functional and the generating functional through the connected diagram and the 1pi effective actions. How can we know that these quantities represent this? First of all, in the statistical physics and the quantum field theory, if we differentiate the generating functionals with n time, then this gives endpoint correlation functions. Then what happened for the generating functionals of the connected diagram? We know that the W's is given by the log of the z. So by that, if we consider the n equal 2 case, then we can differentiate for the first term 1 over the z and the second term from this log z. And there will be the two term, there will be the second derivatives of the z. And we can differentiate the 1 over the z here, so this gives this term. And the first term gives the ordinary two-point correlation function. It contains all the diagram. But the second term, the first terms and the first component and the second component gives the one-point correlation function each, and this gives the disconnected diagram. So the first terms contains the order diagram, and the second term represent the disconnected diagram. And if we subtract the two terms, then this gives only the effective connected diagram. And by the recursive proofs for n equals 3 and all the integers, such as and derivatives of the generating functional of the connected diagram, wz gives the endpoint correlation function for the connected diagram. So this is the first widget. And the second one, now we want to talk about the effective action, 1pi effective action. So we will use many relations from the Legendre transformation. This is both derivatives of the effective actions about the field. This gives the minus a. And by the if we differentiate one more time with the ddz with the source term, then in the right hand side this gives the delta jx and the delta jy. This gives the delta functions from the functional analysis. And by the chain rule, we can give the additional derivatives about the field term. and integrate over the space-time. Then the right-hand side, just this gives the delta functions here. On the left-hand side, we can use the properties of the transformation one more time. dw dti is equal to the pi. So the this term, so the pi can be written by the d delta w delta j again. So the point is that there is we use the properties of the transformations in two time here and here. So the these give the two terms. The second derivatives of the effective actions about the build and the second derivatives of the the generating functions of the connected diagrams about the system J. So that this gives the those two second derivatives terms has inverse relations about the matrix form. This is the delta function here, and this is the general result in the Redondant transformation. So the this is unequal to case. So if we differentiate the effective actions two times, then this gives the inverse of the second derivatives of the generating function of the connected diagram. And we know that this gives the inverse propagator. So let's write the propagators as a d of the x1 and x2. And this propagators contains all connected diagram. And all connected diagram can be obtained by the geometric series of the 1pi diagram. So this is just the tree level, and this is the 1pi, which contains the this diagram. So 1pi diagram means that we cannot cut the diagrams. So for example, this is the 1pi diagram. If we cut this here, then we can devise. In the another videos, I will talk about what 1pi diagrams and in the other compatibility discourse. So if we sum sort of this all the 1pi diagrams as geometric series, and then we can obtain the propagators in the momentum space as the propagators including all the connected diagram. And if we go to the n equals 3 case for the effective action, so already we know that there are inverse relation for the n equal 2, and if we ask the additional differentiations about the J1, so this gives J1, and again we will use the Redondant transformations property. So first of all, the d delta J1 can be written by this one as a chain rule, and again the pi can be written by the delta w delta j, so which gives the second derivative of the delta j here. So this gives the propagators, the propagators against the p here, with the addition of the delta pi w. So this gives the third derivatives of the effective actions, and we use the here's the relations of linear algebra. If we differentiate the inverse matrix, this gives such a form. So there will be the one over the inverse propagator and one over the inverse propagators will be appear. And so the originally there are the one propagators here from the delta dj1 and the two propagators from here as a differentiation of the inverse matrix. So there will be the three propagators will be appear. And we know that the left-hand side is the third derivative of the generating function of the connected diagram. So this gives the all the diagram 3-point correlation function from the all the connected diagram, and there will be the propagators here. So the so these terms, the 1w to u and the v3 gives the some amplitudes the diagrams, and the remaining thing is just the 1pi. So the if we differentiate the refractive the actions, 1pi refractive action, this gives the 1pi diagram. So the here is the final result. If we differentiate of the 1pi effective action gamma with the derivative, this gives the endpoint correlation functions of the 1PI diagram support n equals ladder or the same with the 3. So the point is that 1PI effective actions is also the generating functional as the functions of the scalar field pi, and this includes all the quantum loop theories which is came from the 1PI diagram. And the next time I will talk about the Kolmar-Weinberg's potential.